Hello, here is FA Radio, and welcome to hear our podcast. So this time, I'm Chris. Okay, let me introduce myself again. I'm Chris Young. That I'm come from Hong Kong, but I'm working in Japan and for factory automations. And then you see here is Takahasa-san. Takahasa-san is also a factory is an engineer. He's working for factory automation. Now he's focused on the software PLC. He's a very great engineer in Japan. Okay, so maybe can you introduce yourself, Alex?
Oh yeah, thank you for having me and inviting to your podcast. It's an honor to be here. So thank you. But what I would like to how we introduce. I'm an engineer. I'm a controls and automation engineer, actually electrical engineer. So worked as a controls engineer. Maybe around 15 years altogether. Maybe about 12 years I was fully in controls.
Oh, really?
So, yeah, before this I was doing a little bit of electrical, so design, putting systems together. So the building substation starters with a lot of electrical variable speed drives, and spent some time on the control systems, so building PLC programs and HMIs and SCADAs. So yeah, all together, when I was working, I think the majority, maybe 60% of the time of my experience, I worked with coal mines. So in Australia, the region where I'm from, it's Newcastle, which is in general New South Wales is a state where we have a lot of coal mines. In fact, we have the largest coal export port just next door. I think it's the largest, not in the southern hemisphere, just in the world, as far as I know.
Okay.
Could be wrong. We should ask AI. Yeah.
Okay.
So yeah.
So I know that you have so many experience that from electrical engineer, starts from wiring to the hand working, and then to design the PLC program, and then to maybe also go to commissioning to the customer side. So you did all this stuff in your career. Is that correct? Oh.
Yeah, that's exactly all of this. So design system, program, test it, and go on site and spend a few days on site, or maybe a week, sometimes a month, commissioning. Just to get there are some of the large projects where we just have to spend, and not because of the control system. It's usually so much mechanical things need to be done also. So they're all of this design, test, program, test, commission.
Infinitive loops, is that?
It is exactly.
And you told me where was your country? Where was your company's country? You're in Australia? Is that correct? Australia, right?
Australia. Yeah. So yeah, I moved here, migrated about 17 or 16 years ago, I think. From Russia originally. So and I live here now, and I have kids and all my family here. So but I worked a lot for in controls and automation here also. But at some point I left the company and I opened my own, which is the Control X I have. So what we actually do in controls, in Control X as a controls, we mostly do the PLCs, some SCADA projects.
Okay.
We do a lot of software also development where we combine PLCs and combine to the other IT softwares. So kind of OT IT connections. So we build like bridges sometimes, so to get some data out and communicate to other systems like MES or ERP, but not actually ERP much. We had only one little thing, but there are other little software packages you have to talk to.
Okay. So that's I think the main reason that why I would like to invite you to this podcast is, I think it's sometimes the LinkedIn that you send an email to me that, hey Chris, do you like to try our AI based runtime? Is that correct? And I tried this. Actually, I think I'm being smart. So could it be introduce me, ask me and Taka-san that actually what kind of magic that your company made?
Yeah, that's a good question. So at some point we were doing a lot of software, and a few years ago, right? How many already? 2 or 3 years? 3 years ago, when ChatGPT came out, right? We saw. I still see the power. How amazing AI generates tokens, right?
Okay.
And some of them put together in a code actually works, right? So what we did by making any other projects and working a little bit on the structured text in PLCs, you go in Gemini. I mean, not Gemini, but the ChatGPT before was the first one, or Claude, what we use also a lot. You put a question and produce something, and you copy and paste it to. So we thought it is a lot of work to copy and paste, and AI doesn't know a lot of things. So what if you combine them together?
Combine together? What do you mean combine together?
So what if you have a program which is actually a PLC program-like, which can execute logic, but also have AI inbuilt there. So you don't need to go another window. You stay in one place.
You mean that we can integrate? How to say? We can just ask the ChatGPT, hey, let's do something for us. Then they directly integrate it in the project.
Exactly. That's how Jasper Node was born. That's how we decided to build one.
I hear this
so
name. Jasper
that is
Node.
when we have Jasper Node is actually a decision to put this together and make it easier and simpler for us and other engineers to develop control systems. And I'm saying control system, not only split pieces of logic because of AI doing this very quickly, but architect to create big systems. So that is the first step. A year ago when we started putting them together, that's when Jasper Node was born.
Oh, so it means that this Jasper Node is still very young, it's just 2, 3, or 4 years old still in.
It's only 1 year old. Yeah, exactly.
Really?
Yeah, it's, we are very young. We're just getting started. In fact, that is what we have is just Jasper Node is in the stage when it's production ready, and we're looking for engineers and other testers who can join us. We're carefully selecting people who can, like yourself, for example, who can try out and give us valuable feedback. So we want to introduce that to the people who want to try, know that there are problems, right? So we know things that there are a lot of people scared of AI. How do you put AI in the control system? Are you crazy?
Not just in Australia, in Japan or other place.
Exactly. Yeah, and I understand. Everybody should be afraid of this because of AI generate so much code that is you just sometimes cannot comprehend. If you put it in a system and just run it, it can have a big problems. Right?
Okay, I get it. So could tell me a little bit about your JasperX. So what kind of platform, or do you need? I need to choose some special hardware to run your application, or I can just take a small Raspberry Pi like this to run that. To even about more. How about your architecture of your software?
Yeah, no, it's a good question because of that is usually confusing. Like, what is a controller? Because people used to see a hardware piece of something. So the goal of Jasper Node is to become one software which can include any Ethernet protocols. I mean, all Ethernet protocols, but have any ability to communicate to any Ethernet protocols, industrial protocols, and to be used on any hardware. When I say any hardware, I mean a PC. So we can run on Mac, on Windows, on Linux, on anything you have available for you, you can run it. And the whole idea is to create a system that can can communicate to everything and be ready to execute your control logic you need. But we know that as in reality, you will never actually have like Mac in industrial settings. But what you want to do is you have your own Mac, you install and you program, you create the systems, you create a backup or save file. After you bring over to your little PC, you showed me like a Seed or Raspberry Pi or Revolution Pi, any of the ARM-based, or you can get little NUCs. It's from, I think they're absolutely ready. So there are little industrial PCs you can buy with Windows. You install JasperNode there, and from your development machine, you bring over this package, your backup, and restore there. So you basically develop anywhere on any machine. You create little save file, and after bring to your industrial PC and restore it, and it works.
So it means it's cross-platform. I don't need to care that what kind of platform that I've created the project by using JasperX, and then I just save it, and then I can down in everywhere, every runtime is in.
Exactly right.
Okay.
Exactly.
So I think it is very great that I think now I think not just in Japan, and also European or US, they're also thinking the individual would like to, I would say, choose the hardware. They would like to choose the hardware that they want. So maybe in the old school style, I also use Siemens before. I used Siemens, Rockwell, or Mitsubishi before that. The traditional hardware PLC, hardware PLC. But in your application, the best is you prefer to choose the hardware that the end user they can want to install, to play with your runtime. So is that correct?
Yeah, exactly. So they can play with runtime on any computer. But when you decided to already use it in your automation system, you bring a little industrial PC, which most of the time now runs Linux.
Okay.
You run one command, only one command. I think you have tried before. So Edge just magically installs everything for you.
Yeah, sure. And auto start, no need to care everything.
Exactly. And it's just there, and it's ready to go as a service. It creates necessary, all necessary processes at the back end to keep reliably running.
And do you need any tubes to configure your runtime? Because, for example, Siemens, you use TI Porter, or in Rockwell, you need to use I think it's Logic 5000. So what kind of engineered tubes did you need to configure your JasperX runtime?
Yeah, so that's a good question. So one of the goals of JasperNode is to make it as easy as possible for engineers to use. So you don't have to have anything installed. The runtime already has a user interface.
The runtime.
So whenever you go to this link, that is your user interface. This is your engineering environment. So there where you can see the connectors, where you can see the tags and create tags, delete tags. Also, you open AI agent and you can chat to the AI, and it is all on that runtime. So it's all inside there. So you don't have to have a special software for this. You can become your tablet. Like if you have a Samsung tablet, become your programming computer. Your Mac become a programming computer. Your Windows is a programming computer. You just only open the link to your industrial PC and you start programming.
You mean that your runtime have an integrated web server that we don't need to...
Exactly right.
Yeah, because
exactly.
I think there's a very great things. For example, now I also play with some big company before, European company before, that their engineer tubes is more than 7 gigs for just install. You take 1 or 2 hours, and even it's just for you to control maybe 2 or 3 pumps or 10 bottoms something. Actually, sometimes I also don't know what I'm doing. I
know exactly what I mean because of the same thing. I had a project where I had a new hardware, and it was a Siemens, and I had to install TIA with a different version. Yeah, it's actually have to spend a bit time to wait till it's installed.
Yeah.
I was on site at the time. I was actually on site, sitting in front of this cabinet, super hot day, and I was just hiding there and trying to program. And yeah, it probably took a couple hours to just install things.
Okay.
So I don't think it's a good approach. I don't think it is. I think it should be fixed, and we're fixing it by embedding the web interface inside the runtime.
Okay, so then maybe let's shift a bit to your runtime. Then you told me that you have an AI assistant. So you told me what is your AI assistant in your runtime, and how does it work? How can they help the engineer to make their life to be more happy?
Yeah, no, that is a great question. So this is the I think this is probably maybe the first who is AI based and AI first PLC or controller, software controller. So we build everything about that is AI has the more power than the engineer. When I'm saying more power, it means to modify and to figure out things it needs to.
Okay.
So it has access to little things, so many of them. Every engineer can also look into this what they want to in like configuration files, but they can be long. But what we do that is AI has access to everything, but only acts when you ask. So it is very. So we also, when I started using this, we have a few projects, around maybe 10 different where we have Jasper now running, and we were also cautious and worried about what's AI going to do. We didn't want to. I mean, I don't want to wreck my machine, my equipment. It's a client's machines, and if something goes wrong, I have to pay. So I didn't like this. So we did the system when AI is really, really much guardrailed. So it has the system in place where it designed the way that it's only can implement one task at a time, and when you want to, it can confirm every single task when it does.
Any single task? You mean that it's not running cyclic? But for example, okay. So I mean, this question I will ask you a little bit later. Let's focus on the AI assistant first. So how it works? What, for example, how to say? The AI assistant, I think, is integrated into your runtime. Is that correct? Okay. So how does it work? How can I play with that AI assistance?
Yeah, that is one of the misunderstanding. People think that AI does some runs something. So, but what we do, we have a very similar architecture to the PLC. We have a logic.
Yeah.
We have inputs coming in, logic executed, outputs comes out. Inputs come in, logic executed, come out, and it's cycle, typical cycle as a PLC. With the maybe three different things we brought into to make AI more reliable. First, this logic in the middle, all this logic can be modified by AI or by you. But it has a very careful thing we implemented. It's called atomic tag control. So atomic, that means only one tag can be changed by their own script. It's a bit difficult to understand. I might show you a little bit later how
this actually is running.
Yeah, how it actually looks similar to Siemens or to Allen Bradley or even Node-RED. I have an example to show. To give an example, what script and tag is in Node-RED or in TIA.
Okay.
So, but anyway, so we decided to have this. So only one tag can be executed by script, and script can be changed by AI. This first. Second thing is that AI also have access to modify these connectors, where the input's coming from and where it comes to. So, for example, when you go to let's say Siemens TIA or any other development environment, you can create additional hardware.
Yes.
So in our case, AI can create the configuration for this.
Oh, you mean that, for example, I would like to I would like to create a network with Ethercat just with these 3 or 4 nodes. Then you can just create a chat with your AI assistant. The AI assistant will automatically create all the conversion for you.
Exactly. Correct? So in that backend, it create this all configuration for you. Like if you go to PodSys and you go to Ethercat, let's have so many little settings.
Yeah.
So our AI does it for you. So we don't even have that thing. The AI does it for you. You just ask that and it creates it for you. You still have an option to go and have a look. It's usually in text now. We don't have the user interface yet built properly for this. But you have user interface, but very limited. You can see in quick little things. But the whole idea is to be AI first. So you just ask what you want. And after you can polish different places by yourself if you like to.
Okay, I get it. So it's maybe very powerful tools to maybe to change what we do for the engineer works before. Because I also work with a PLC more than 10 years. We need to open the drawing and then to check out what kind of module that we need to install in our project, and then we need to install it one by one to define the tasks one by one, and then we can start the programming. So it means that your AI assistant can not just to create the logic, can also create the conversations. What kind of stuff they would like to connect? Is that correct?
That's exactly right.
Oh, that's great. And I would like to have a question that you say that your AI assistant can create the logic. So what is the language that your JasperX system can create? What kind of language will your
that's you just jumped into the third part of what design decision we had to take is that we decided to use JavaScript. JavaScript, yeah, exactly. The reason is because of we didn't aim to create firm real-time deterministic systems. We wanted to build the controller for general automation where 5 or 10 milliseconds is not a critical delay.
Okay.
So now we have a question. What language is most popular in the world? And it's two languages come up. It's JavaScript and Python.
Okay.
So 2 languages. That means the LLM knows really, really, really well. So what our goal is to ask LLM to create the logic for you, and we want the LLM to be right. So we want the LLM to create logic which works. So if the LLM knows very well JavaScript, so we should use JavaScript. With Python, we didn't want to go ahead with Python. Only one reason, because it's too slow. Because if we actually raw runtime is JavaScript runtime, the Python is much slower.
Actually, it's pure JavaScript runtime is.
Correct. Yeah. Exactly right.
So that your logic, all the logic you created from an AI assistant is JavaScript.
That's exactly right. Yeah. So everything underneath is JavaScript runtime. Have you heard about Dino?
I think I think it's a real more fast run. It's more fast than Node.js, right?
Exactly. Yeah. It's a two alternatives now to Node.js. There is a Dino and Bun. So we use a Dino, and so they're all program written in this. It's just because of it helps us to create a very quick, great program. We have a roadmap. We have an idea. We want to move further to deterministic systems later. We're already putting few little bricks of the Rust. So our Ethercat connector is written in Rust.
Hey, wait, you mean you have Ethercat connectors now? Your runtime?
Yeah, exactly. Yeah. So our runtime can speak to EtherCAD devices like back off behind me. And we wrote this in Rust. We actually used somebody else's library, but we had to write additional functionalities to cover what's needed.
So when the EtherCAD is right by your team, it's done by your team, the stuck.
Yeah, exactly. Yeah.
Because I'm very surprised that when I meet Alex is I think it's last year around October or something, right? October or November something, right?
I think so.
Yeah,
I think even September. I think September, October.
Yeah, and that time you told me that you are still delivering EtherCAD. Maybe it is sometime that in January, in this year January, you told me, hey, we did the EtherCAD, please see. And then it works very well. I'm very surprised that how can you do that? Because I don't know, you're not a very big company. I don't know how you can do this task very fast to implement the EtherCAD. And I see your roadmap also EtherCAD. You are now trying to implement Ethernet IP also. Is it correct?
Yeah, exactly. Yeah. Ethernet IP is going to be our next. We have actually 3 more coming. Is this Ethernet IP, OPC UA, and BACnet.
BACnet. So your the runtime will also focus on other field, not just factory automation. We go to the field building automation also.
That's exactly right. We're building a software controller, which will be talking to any Ethernet protocols. Eventually, we'll have all Ethernet protocols there. It just takes time, but eventually you'll ask AI, connect to this device, and you take a photo of this device, saying, "This is device. I don't know what it is." And AI will figure out everything for you. It will know what the device, it will try things. We have tools like a ping, so our AI can ping if it needs to. Our AI can check the traffic on the network. Our AI can, inside Jasper Node, can do a lot of troubleshooting on network to find out what's available, how it works, if it's connected, if it's not connected. So that's the system.
You mean your AI is not just a tool for the engineer to create a project or to create a machine? Also after the machine is done, can also do the diagnostic stage and for the maintenance, for the troubleshooting. Is that correct?
That's exactly right. So this is it's one of the reasons what we use with other clients, Jasper Node, is when you have a system and something breaks down, the person who has no idea about the control system can ask, what's happening with my system?
Okay.
You can, in plain language, come over, like the operator. That is, we really want to have a maintenance team to be able to solve the problems by themselves, by just coming over to the machine and saying, this motor is not running. Tell me why.
Okay.
And AI can do troubleshooting for you. It's not going to change anything. So it's not the tool for change.
Okay.
So I think your version still doesn't have it, but the newer version in AI box, it's going to have ask or change. So you can switch it to ask, and AI will have no any rights. Rights to change anything. It will only look through, ask you questions, look through more, and will help you to troubleshoot.
Okay, so thank you. So now I know that your system can, in your just no runtime, the core thing is you can use AI assistant to create the logic for you, to create the conversions for you, and to have the troubleshooting. And also it's running in Java. Actually, not just the runtime, and all the logic is generated by JavaScript. And this because it's the most famous language in the world now. So I think I summarize now. So the next question is
you did well.
Yeah. So because I'm very surprised that the first time I hear this type of architecture, I didn't mention it. How is Jesus? It's very clever, this guy. How they config this type of runtime. Okay. So my next question is your AI assistant. So your AI assistant is in the runtime. So actually, in that time, we need to connect the internet to your server, to LM server. Is that correct?
Exactly. So you'll need to have internet to program at the runtime. So how it works? So this is the cycle always works and execute logic. The actual logic you have, it's in runtime, saved on the machine, on this computer you're using. So if you used an industrial computer, it still sits there. All the values will be saved always. So everything saved on the disk every time, every single run, everything's happening. But when you need to program this, you have two choices. One choice is the option, which is you go and open and manually look for the code and change it. So you will be able to see the actual logic, or see the actual JavaScript language code. So you can modify this a little bit if you need to. Or you can connect the system to the internet and then ask AI, hey, so I have this problem. Or let's say not a problem, maybe let's say we bring in new 5 inputs, or we have extra motor here. Let's get this new motor commissioned and tested. So AI will do all logic for you and it'll help you to commission and test you. But for that, you will have to have internet. You will have to have internet to communicate with AI. So when you finished, so that's it. You're done. You commissioned your system running. You look at this, press buttons, looks good. You take and disconnect the internet, and that's it. So the system will keep running. So the same logic was there. If you turn it off, turn on again, turn off, turn on, it'll be just everything the same here, there, and keep running.
Because this is a very interesting stuff that because yesterday we have a podcast me and Takasa is talking about the cloud PLC, and that time it's made by Toshiba. We have Toshiba, a very big Japanese company. They will put their own whole controller and the logic on the cloud. And then inside they will they use some special technology to make the very high speed communications, only 20 milliseconds something to control the IOs. But their own their logic will be on the cloud. So but for your solution, that your logic is still in the local side. And then, for example, to control the logic, to turn on the motor, to get the data from the sensor, all this logic or all this control mechanism will be still in a local machine. Is that correct?
Exactly. Yeah, we just want to keep machine running. So we don't want to have, if internet's gone or anything, we just want the machines running. So it needs to keep running.
Okay, I get it.
And if you want to manage this, because I know people, the reason why we do this, because sometimes management is very difficult. So when I have hundreds of different machines, we have JasperX. JasperX, it's a platform in the cloud which communicates to nodes. And if you change something on a node, if you still have internet, you can create snapshot. It creates snapshot there. So if you have a Jasper node hardware broken or whatever happened to it, you take it away and chuck it in the bin, bring new PC, and go to JasperX and deploy there. So it deploys the whole what it was before. They have exactly the same configuration, exactly the same logic, and it just runs again.
So we mean all this small runtime, it have a nodes that is run on each local machine, but you have other platform called JasperX to JasperX to control to manage all your nodes. That's why I call it X and nodes. I get it.
Yeah, exactly. X is like a central place, and nodes are everywhere.
I get it. Exactly. So it's very great. And how? Actually, I have other questions. How? I know that most of company they you use the AI assistant. They need to pay. And could a little bit know? If you think that's okay, could you tell me a little bit about your business model? How? I think the people cannot use your AI. It's free, right? But could you tell me how what is your thinking of your business model?
Yeah, so with business model, we want to be always fair to people. I don't like too many subscriptions. Sometimes you don't use things, and subscriptions you have to pay. So we decided to not use subscriptions for AI here. we basically creating a tool with a connection to AI. And when AI is used, how many tokens you have to pay for that? So you pay as you go. There are obviously the benefits and disadvantages for that model, but this is how we started. We're already talking with one of our potential clients who wants to have an actual subscription. So I think we'll be flexible. We'll probably have two different tiers for whole time. One of them will be you pay as you go. Like let's say you have 2 projects or 3 projects a year. You bring in, you program your system, you install the machine, disconnect internet, and it's running. You don't have to pay, you don't have to do anything. So it's just running. Whenever you have to come over, troubleshoot, you connect, you pay for that use and disconnect. Or some of the clients who have like you just said, like large organizations you work with, like Toyota or any other you used to work with, they probably don't like this idea.
Yeah.
They want to have same cost every single month. So for this kind of organizations, we're going to have enterprise version where we just introduce subscription, and it'll be easier, and there will be probably some particular limit on the tokens, because if they're using millions and millions and millions of tokens, it still can be very costly.
So it depends on how they would like to use your, how much they need to use your AI. If they need to use more, and that time they also have a subscription plan for them. But if they just use for troubleshooting or something, you can just pay what you do. So
exactly right.
So even I think even that I don't want to use your AI assistant, I can just use the runtime to try to program by myself. Is it correct?
Yeah, exactly. You can do everything manual. Everything you can do AI, you can do it yourself.
Yeah, because I feel very surprised that you didn't charge on your runtime. You didn't charge on your tubes. You charge on your AI assistant, and then you told me that it's a charge if you use it. I think it's very surprised. I didn't see this sort of business model before. Very surprised when I introduced your platform to him a couple of times. Every time he said, they're very surprised that why they can make the business model like this.
We think it's going to work.
Yeah.
This is like, I think it'll be the future. So you want to use AI and you want to pay when you use it. I thought about this a lot, and I think AI is going to be very similar to electricity. Like that's what I think. It's going to be another commodity when you will.
It will be just like you open you can drink the water from your home. You can turn on the light, turn on the switch, the lamp will be turned on. It will be, if it close to you, then you don't feel it's the AI anymore or something like this.
No, I think in terms of the payment, like how do you pay for electricity, right? You turn switch, you use it, and at the end of the month you pay a bill.
Yeah, sure.
Is it like this in Japan? I don't know.
Same. You did pay how you use. Yeah, same.
So I think it'll be same with AI in the future. It'll be doesn't matter who produces tokens for you. It will be all of them. Open AI,
Gemini,
XAI, Anthropic or Claude or Google. Whoever produces for you, you probably will have one supplier who will switch between them, depends on your task. And you probably will have just pay to the supplier. So you don't really know what models they're using. They will choose depends on the task.
Okay.
And I think so. I think that's how it's going to happen because of this technology, which will live with all the time. It will be here all the time. And I think how to make money is all the companies. They will just produce like electricity. They will keep producing these tokens for you, and you're going to consume them and pay for these tokens. And you use more this month, less next month. I think so.
Yeah, because I know that for example, if you are living in EU, for example, Siemens or even Lockwell or Beckhoff, they also try to do their AI assistant, right? But they didn't. Now I think they now or still in 2026, you still have a very clear business model, how they charge to the market? Or I don't want to say too much in here. Maybe they would allow you to use free at the first 3 months. And then one time they say, hey, we'll start from charging this month or something. I don't know what is their business model. But when I talk with Alex, talk with you, that I'm very clear that what is your target, and what is thinking about AI, and how you can save our lives. So yeah, I feel like your solution and your business model, and I'm very surprised that there's something like this.
Yeah, no, it is going to change a lot about what we do, and it will help controls engineers, automation engineers a lot. It's regardless who is going to bring it, us or any other companies. It does great work, but what we have to do as a tool provider, like I am making a tool. My job is to very carefully look into where AI make mistakes and remove them. So when you use the system, you feel comfortable with this, you trust it, and it produces great results every time. And if it doesn't, it has to alert you or ask questions or follow up with the system it doesn't understand. So it's a lot of problems every single LM has, and I know that Claude and Google and other work on this, or OpenAI work on this to make it better. And our job also now as Jasper Node, I don't want to damage equipment or injure anybody. Right? It's not something I ever wanted. So my job is to be very careful with this, and that's why we're looking for the testers who can test with us carefully. We can find these old bugs and problems. But we went far. We have a really good system now. It just has so good. This chance that is making mistake is so little.
Okay, I get it.
And so we're making tools to test this, so you can have trust in it.
Okay, so I think now we talk with 40 minutes, and I think it's now the time to give you some real demo to our listeners. Is that correct?
No, exactly. Yeah, I think probably it's a good idea to give a little bit of an idea how it's.
Because just talking, I think the people say, "Hey, is that true?" Yeah, they say it's AI based something. Is that true or not? Do you know how to share your screen?
Do I share just here in that?
Just share.
Okay.
No. You can share the screen now. You can use right now using Google. You can just directly share the screen.
I will try to speak through what I'm doing because of some people listening, right?
Yeah. Don't worry. We'll upload as a video. So don't worry. Just we see it. Okay, so could you show it something different what I see before? Did you update it? Hey, is the new version?
A little bit different. Yes, exactly. What you see here is just the home screen. They usually what we want to show the connectors. We have 2 different groups of connectors where we call some of them as the hardware connectors on the left side, and you can create extra connectors, or you see already existing ones here. And the connector is basically where the data comes from to Jasper Node. And we have IT connectors, which are where data goes out or also can come in. Where also another side. We're showing just 2 different sides to make sure, because the hardware connectors, you want to have a fast and reliable and high priority to execute anything. And software connectors, it's a less priority, and it's data usually for monitoring or for reporting, basically.
So your system split to 2 types of connectors. One, the hardware for the wheel control, that control the I/O, so for the pumps or to get a signal from the sensor and the high priority. And the right hand side is the software controller to connect the IT system, like database or some stuff.
Exactly right. Let me just switch to the light mode because I think dark mode will be not really easy to see for some people. I'll just switch to light.
Okay.
So it's straight away bright to us, right? So yeah, anyway, so this is the connectors on the left side and other connectors on the right side. We have a little bit of here as a dashboard, shows you a little bit of information, what you want to show here. That's all of this can be adjusted, so you can bring anything from your program. So it's quickly to see some values. You can toggle things, you can run things. You can see the values changes, but this is only for just little HMI dashboard. Just very quick one.
Oh my
Not
god!
HMI.
I did
Just very quick.
I didn't hear this features two weeks before. I didn't. no, last week I still didn't hear these features.
Yeah, no, it's a lot of things coming. It's
Okay.
it's really good. It's great.
So this dashboard is directed to link to your tasks. You can directly turn off, or you can directly see your tasks.
Exactly. Yeah. Here, this is basically. I can jump in quickly, but I don't want to. No, I don't. I'm sorry. I will continue just in the flow.
Just take your time. Now is your show time. Let's take it.
So yeah, there are two ways you can create connectors. There is a manual here. You can click on the one you want to create. Let's say you have a Modbus device connected to your hardware. You press the plus button here.
Okay.
And you fill in the information as usual, new config, put IP address, and other details like registers here and addresses. So you can set everything manually here.
Okay.
But also from the home page, when you press plus, it actually opens to AI.
Oh, this one. Let's see.
Yeah, and you say, and here you probably can just simply say, create a Modbus connector, and you probably want to do maybe some IP address and so on. So you put the information right here. Let's say this address, and it will run and it will start creating connector for you.
Okay.
But only if you have auto run. There is also agent with approval. Okay. So when you click run with approval, it will ask every stage. So it will not do change unless you confirm. Or you can put in ask and just ask a question. How many Modbus connectors I have, and what does it do? Let's say, and what it does, it's just goes and trying to figure out, okay, how many connectors you have, how they look like. Okay. Sometimes I had errors when it's trying to run two of them. And it goes through all of that by trying to describe everything for you in the language you'd like to hear. So that's it. We have a Modbus TCP connector client. It tells you how it's connected, what's IP addresses, cycle time.
Okay, and what it does.
And we have a server, which is also, and how many registers it has. It says the server is serving everything from HMI page, and you have temperatures, you have discrete inputs, and so on. So you can ask about your system in just one quick sentence instead of jumping through everywhere. But you could do it yourself. You could close it and go and look and read and see everything here.
It's more
or you go and you can see, okay, you have a server, you have path, you have port, you have one variable, another variable, and so on. You can look at them and see. But you could ask AI, so you could do it everything yourself.
So it means for the ask features. So is that possible to let the AI to analyze what the project that I'm doing?
Yeah, exactly. So you can when you knew, for example, you had the 5 engineers before work on some systems, right? Some particular system where have a Jasper node installed. When you come in, you have no idea what's going on.
Yeah, sure.
You can go to ask mode and say, what does this application do?
Yeah, because it's very painful that every time when I go to site, I need to upload the program and I need to check the logic. And that time I need to imagine what is the program is running. It's a very painful.
It's exactly. But now it tells you this is sorry, just keep scrolling for me.
Okay. You also analyze the fuel bus.
So it tells the application is PIC reactor temperature control.
Okay.
So it's a main purpose. Control a heated mixing vat vessel, automated temperature regulation, and safety interlocks. So it described to you the process, described what hardware you have connected. We have Logo PLC connected, we have Modbus connected, and I have EtherCAD, which is Beckhoff EL2008 unit. It describes the control logic, what it does, and system, how it works, and what's something special about this. It actually talks a little bit about Jasper Node. I don't know why I decided to do it, but I decided to add this.
But it's very helpful. Very helpful.
And you, as a new engineer, you just quickly understand what's going on. And you can go drill down into particular things you want to know.
Okay. So now we know the ask. And could you show me how to create the logic? How can I create the logic by using your AI assistant?
So here in automation design, that's where you go and see it. This is usually all the systems. We usually ask AI to create summaries. So this is as a summary of your system. You can always see what system looks like. So you can ask AI as soon as you program. You say create a tag with the explanation. Or here, this is my README file. You can see what's actually system does without asking AI. You can always have it inside your program just to describe what it is. So we always like to do it.
Okay.
But if you want to add logic, for example, let's see, we have a HMI right here. HMI tags. Let's say I want to add one more here. Let's say, which one do you want to? We have a controls. We have over temperature alarms here, heater interlock. So from this control, they have a heater interlock. I can go here and say, I will just go without approval and say, add. I just copied this tag. Tag to the HMI folder. So what it's going to do is going to check this exists. And next, it's going to find out what it needs to do. So what it does is duplicate in the tag. And now if I go back to my HMI, it's already here and ready to go. It's disabled to run. We can enable here, or just keep it disabled. So we keep it enabled. But the what it does, it's duplicated and usually have exactly the same logic. But you want to see, you probably want to see the you want to see, let's say controls. Does it have a?
So this
it's a very basic. Wait a second.
Basic. So, I think the listener also very interesting. What kind of logic or what kind of stuff that your system will create for them? Because you told me that your system will create the program in JavaScript.
Yeah. So exactly. So basically, this is system enable, right? And if you click on that button, that's just you can modify the script. So this is script how it looks. That's what's AI generated, and you can do it by yourself.
So it depends on if you want to do yourself or not.
Yeah, exactly. But when you start using it, you'll be doing zeros. I used to do it a little bit by myself. But I know JavaScript very well, but I don't do it anymore. I only rely on AI. I also only read what AI tells me.
okay.
Because sometimes it goes like, oh no, you're doing something wrong. No, stop.
So that's
And because sometimes I'm too ambiguous with my question, right? Because my prompt sometimes create a connector. I didn't tell anything about what device. I didn't tell anything about IP address. I didn't tell about what registers we have. I just say I'm so ambiguous. That's why I start guessing. But I usually stop and say, okay, let's add this information to you, and AI gets really, really good in this.
I get it. I
think we have maybe more complicated. Do you have more complicated? No, it's just, this is just a scale, and so it takes raw value and creates for you
I get it.
A voltage output.
That's great. I see the whole. Now we can access by just using Chrome or Edge, the web browser. You don't need any specification, as you mentioned before. Yeah, that's great.
Exactly right.
That's great.
Yeah, exactly. I have a little thing here I want to show you. So sometimes people don't understand when I'm explaining that is we have this is a tag.
Yes.
This is my digital output. Let's say I have which one will be more complicated? I probably will try to do this. Okay. So at the back of my background, I have this tower, right? If I'll change it to true, you can see I'm overriding this output. I'm actually writing this output like a force in this output. So now I see who is actually triggering this output. So if I want to troubleshoot something, I come here, and if my output is not working because of only one place where you can change this tag, it's only this script. This is called atomic control. It's only one place. So nowhere in a program, in any other scripts, I can change this tag. Only this tag. So I go here and I look, so mixer run is only one thing which triggers this output.
So in the whole project, one digital output or one output can only trigger by one script.
Exactly.
You cannot deal with it.
So now I go to this tag, mixer, that one, and now I see logic. So I can see logic and also see who is triggering this logic. And now I was like, that's a system enable or system alarm. What does overtemp alarm does? So I'll go and look on control overtemp.
So
I go to control overtemp and I click here, and now I can see what's triggered this. So can you see the logic? So because of one output is only in one place, you can have these links. And we have even little diagram. When you click on this folder, you can click relationship. You can see how they all interacted with each other.
Is it new features? No, it's the old features.
It actually was before, but we're still working on it because of that is very helpful. So eventually you get to this heater. And this is digital output one. You can see who is actually what particular tags are influencing it. So it's actually started with the temperature, the raw temperature, and after temperature, and end up in digital output one. Hold on. Did I talk about 1 or 2 or 0? I think I talked about 0. Sorry, I actually talked about 0. Yes. So we talked about this mixture, and now the mixture is over temp and system enable.
So this type of flow, your system flow is always focused on the output. The output is turned on from where, and then to find out where to trigger upon.
So this is very important. That's actually, I've said it so many times, but this is very important because of that helps AI to make less mistakes. When you have a program where everything in one place, one mistake can be crucial and big problem. Here, something will just not work, but the problem will be less happen, like the mistakes less happen because of the AI knows the structure. And if you break somewhere in the middle, something will just not work, but nothing going to be crucial happening, like a bad's happening.
So I feel probably like your questions that don't let AI to make the mistake.
Yeah, we don't let them by creating very tight and specific system for the AI.
So that's why you
Saying
make
you cannot do by another way.
So
you cannot be super free. You just focus on one tag. That's what they're asking.
So that's why you generate the system with the output can turn on just by one point. If the program can turn on one output in different of a subroutine, that maybe your ARM server you make the mistake. For summarize, where is the point to trigger the output?
So AI, it helps AI to troubleshoot, and AI making less mistakes by doing this.
Okay, thank you. And I see now I see your connector now still have Modulbus and EtherCAT and S7 connectors and Lego. So I think in the future you also increase more and more, right?
Yeah, exactly. It will be the hundreds of them here. So we'll add all of them.
Okay. Could you show me the diagnetics? Diagnetics. What kind of information can we see in your system? Yeah.
Diagnostics, did you say?
Yeah.
This is the very basic one. It's a big log of information. What's happening.
Thank you.
It's the same thing. If you hear, you can quickly see that log what's happening. If you have errors, error will come up here and tell you it's has an error.
Okay. So and then all your JSPN logs can be controlled at your whole platform called JasperX. Is it correct?
Yeah. Yes. Exactly right. Yeah. So so the whole goal is to manage, because we have a few projects and we want to know some of them faulty or some happened. We have one place to look at this. So JasperX gives you just visibility to all of them. You can do you can do everything. You have JasperX. You can have a look there.
Okay.
Quickly here, I want to mention one thing for engineers. If anybody's still looking and still here, this is actually representation of what script, triggers, and tag is. So if you go back here, if you go to any of these tags again, let me just quickly go and let's say which one we were looking at. That one, right? Mixer.
Yeah, mixer. Yeah.
We have a triggers. We have a script. And we have that tag. So this is the fourth.
Okay.
So if you look at the node red, for example, there's something at the end. You can say this is a tag. Anything in the between, this is your script. And this is your triggers. So something triggered to get your flow working, and you actually got a tag result. This is very similar approach. If you are using TIA portal, look here.
Yeah.
These are your triggers.
Okay.
This is a very basic script. So that's what we have. Sometimes scripts actually getting super long.
Yeah.
But most of the time they're simple like this. And this is your result of your tag.
Oh, they're very clear. They're very clear pictures. Yeah.
And if you are Bradley person, the same thing. Look at this. This is 1, 2, 3, 4. 4 triggers. So one of them will start triggering the entire process here, entire calculation, not calculation, just logic, basically, ladder logic.
This is your script, yeah.
And eventually you have only one tag out, is that result.
I get it.
So that's what we have all in Jasper node is hundreds of these networks around or flows.
And separate to trigger, script, and result.
Exactly. So now that's secondary running. It can be a trigger in other logic, right?
Yeah.
In another script.
So this result may be other results to trigger. I get it. So actually, I think the concept is not so it's very similar to actually what we done before. And you do it in a very similar way.
Similar to the PLC. It's very similar to PLC. But we are trying to solve that the way that is AI makes less mistakes.
I get it. Okay, thank you. And I still 1 hour. We talk about 1 hour. Yeah, don't worry for listener because
I hope your audience still with us.
I don't know,
So-
but I have to say that for last week I talked with Alex more than 2 hours. Just for talk. And
We
okay,
just had a little conversation.
Okay,
Decided to speak
so-
for 30
yeah.
minutes.
yes. So okay, now I would like to know a little bit more about what is your roadmap. What is your next step? What kind of stuff? What kind of magic you like to you would like to implement in the maybe next 2 months or next years or in these years?
Yeah, that's a good question. So, our one and important mission is to make an automation easier. So we want to have all the processes which are tedious and boring, give it to AI.
Okay.
So what we're trying to achieve now is to all these configurations to connection to something should be done by AI.
Okay.
Because this is sometimes boring and annoying, and sometimes you don't even understand why it's not working,
Yeah.
and you have to spend so much time just to weaken things. We want to AI do this. In terms of logic, all logic, if you look into any PLC logic, rank separately, they're very basic. So that can be also done by AI. But what we want to do by humans is that is what I'm now enjoying doing a lot, is to architecting the system,
Okay.
just to designing what sensors and everything I want to use, how it's connected in real life, and the rest of this tasks are given to AI to solve. And now if you're talking about sensors, we talked about the video another day. It can be hundreds different protocols,
Yes.
different configurations.
Yes.
So our goal is to achieve that as it becomes so seamless and easy. So you only tell what device is connected. And actually, in fact, with EtherCAT, we love EtherCAT so much. I mean, I love this protocol because of it actually tells you what's connected.
Yeah.
So you don't need to even know an IP address. So you just go and you can discover on your network what's exist, and it tells you.
Okay.
So yeah, that's the roadmap. Basically, implement protocols, improve our AI, and make it management easy. So you have 20 different nodes, different places. You go to JasperX, you can see all of them there. You can easily connect to different of them, see what's the status of them, if they are running well or any issues with any of them. So the all management becoming easier.
Yeah. And because why I ask these questions is even I did see all this, and now just seeing this web server is totally different, not the same I see in last week, and they're doing very very fast. And he told me, hey Chris, we will last year, hey we will release EtherCAT on next year, and then in 2026 in January they released it. So and I see their website. I always browsing their website to see what kind of stuff they release. I see they and for the Ethernet IP and for the backlight, they're still in testing phase. They will also try to implement so many different protocols like OBCUA or something in this year. So I think they will let us to be more easy to collect the data from the field bus, not just field bus, also for the other IT side software connectors and hardware connectors. And actually, I feel like this solution really, and also would like to try to tell more people in Japan that we love PLC. Actually, I love PLC also. I would like to play PLC. I would like to play servo. And after I talk with Alex, then I know, hey, I think there's so many different ways to finish our task. And Alex told me that, hey, you can maybe use AI assistant. For example, you only have 3 or 4 prompts with a 10 switch. Actually, you no need to use something like TI Proto, a very big software to buy PLC do that. You can just scan the network and then ask AI assistant for what you want to do, and then check it and then finish. So I really like this approach, and maybe this solution will be not can focus on the very high end need maybe less than 1 millisecond application. But I think for the 10 millisecond application, or even some application is running in 100 milliseconds for the building automation. Maybe in this time, Alex, GPS Note is very good solution for this type of application. Yeah, is that correct?
Yeah, absolutely. Yeah. No, exactly. Yeah. The if you have very time critical applications, not recommended. But if you have something process, pumps, general industrial, that works so great. You should use it.
Okay, thank you. And don't worry, I will focus. I also will talk with Alex. I think I have talked with Alex 1 month, 2 or 3 times to communicate. So if they have any great magic that they release, I will let all the Japanese listeners to know. Don't worry. Okay, so I think we talk more than 1 hour. So Alex, do you have anything that would like to say with our the listener, the Japanese engineer?
Yeah, I actually would like to add that is if you're an engineer in Japan or any other country listening to this, stay open, try things, be open to AI tools. I know that gets sometimes annoying, but be open for this. It's some of them very helpful. If you'd like to join our program of early access, please contact me. Just connect with me on LinkedIn, and we can work together on some projects you have. So we will be happy to help you, and this way you probably can help us.
Yeah. If you feel shy, you can just ask me. I can ask Alex. Don't worry.
Exactly.
Yeah, he's a very great guy, and he just paying me that, hey, we're gonna try it, and send me comment that I tried, and then I tried this very great solution. That's why we have this podcast.
That's great. Yeah, thank you for the podcast too. It's great.
Yeah, because now I think this podcast is a collaboration. It's my first time to this collaboration, but I really feel very like Alex. It's very great guys. Yeah, I don't would like to learn so many different things. And last time he just asked me, hey Chris, could you teach me something about IO-Link? I say, yes, okay, just book a meeting. We can have a 2 hours meeting for just talk about IO-Link.
Exactly.
Yeah. Okay, so I think you talk about 1 hour. I need to let our listener know that actually Alex now is around 11 p.m., right?
Yeah, it's 11:20. Yes,
yeah,
exactly.
So I don't want to.
I have to go to bed soon. For sure.
I don't want to take you too much time. I think it's your drive to your home, right?
Yeah, exactly. Just drive. It's okay.
Okay, so I think our podcast will be ending here. So I think Takahashi-san, do you have anything that you would like to ask with Alex or some stuff?
そうですね。英語は聞いてたんで、内容は分かってるんですけど、ちょっと翻訳してもらっていいですか？
はい。
はい。アレックさんありがとうございます。ですね、製品はもともと知ってたんですけど、今回アレックさんの、その思いだとか、製品だとか、いろんなものを聞かせていただいて、本当に、なんていうか、将来の楽しみな製品だっていうことが、より強く分かりました。これからも期待してますんで、続きの開発待ってますんで、頑張ってください。
Okay, so Takahashi-san said that actually he loaned your solution before, yet you I talked your solution to him so many times, and he thinks it's also it may be also a future that of what factory automation can control the machine line, and he is very interesting. He would like you to go forward and forward. He would like to see what is your next magic can show to us.
Oh, yeah, perfect. Yeah, exactly. We will be. Yeah, we'll go forward, and with the factory automation. At some time, we'll get this our deterministic version released, and you can use it in any applications.
Okay. So thank you for Alex, and thank you for Takahashi, and thank you for me.
Chris, yeah, thank you so much for this.
Okay, so please have a good night, and I think I will book a meeting to you very soon. Okay,
no problem.
Good night. See you. Bye bye.
Guys, thank you.
Good night.
Bye-bye.
See you.
See you, everybody.
Bye-bye.
Bye.